Unlocking the secrets of carbon-based chips, the revolutionary tech that could redefine the future of semiconductors is here. How will it reshape the tech landscape? Stay tuned for a captivating exploration into the next frontier of chip technology. Carbon-based chips, or semiconductors, are created using carbon-based nanomaterials like graphene, carbon nanotubes, carbon nanofibers, and nanocarbon spheres. Currently, the majority of semiconductor companies utilize silicon-based chips. However, with the ongoing reduction in chip size, particularly as the chip manufacturing process nears 2 nanometers, silicon-based chips are reaching their physical limits due to material constraints, device limitations, and quantum physics challenges. Consequently, an increasing number of semiconductor companies are turning to the development of carbon-based chips. This shift is driven by the fact that carbon-based chips boast processing speeds that can surpass those of silicon-based chips by up to 1,000 times. China has notably excelled in the research and advancement of carbon-based chips. What benefits do carbon-based chips offer, and how advanced is China in this technology? Carbon-based chips are hailed as the new era following Moore's law. Let's explore their advantages. Regarding performance, carbon-based chips exhibit superior efficiency and lower power consumption compared to their silicon-based counterparts. The manufacturing process for carbon-based chips is simpler, requiring no photolithography. Additionally, carbon-based chips feature ultra-thin conductive channels, offering high stability and carrier mobility, leading to significantly reduced power consumption. In terms of limitations, while silicon-based chips hit a threshold around 1 nanometer, and TSMC is currently tackling the 2 nanometer process, carbon-based chips present a different scenario. They possess lower limits than silicon-based chips, with silicon transistors losing stability below 10 nanometers. In contrast, carbon transistors, such as graphene, maintain stability even at a thickness as minimal as a single carbon atom. This paradigm shift towards carbon-based chips signifies a promising future, especially with their potential to outperform silicon-based chips. Concerning graphene, its thickness is a mere 0.335 nanometers, equivalent to 1/2000th of a hair, yet it is remarkably 200 times harder than steel. Carbon-based chips incorporating graphene are anticipated to deliver tenfold the performance of silicon-based chips, coupled with a 25% reduction in power consumption. For instance, a carbon-based chip utilizing the 90 nanometer process is expected to yield a silicon-based chip with performance and integration comparable to the 28 nanometers technology node. Essentially, using a 28 nanometers lithography machine achieves results comparable to the world's most advanced EUV lithography machine. Given the significance of carbon-based chips, the United States is naturally showing keen interest. How is the development of carbon-based chips progressing in the US and other countries? The US embarked on the exploration of graphene electronic technology early on. The National Science Foundation of the US has initiated numerous fundamental research projects on carbon-based electronics, encompassing all facets of research and application within this domain. The US Defense Advanced Research Projects Agency allocated a substantial investment, reaching up to $1.5 billion, for the Electronic Revival Initiative launched in 2018. This initiative aims to explore future integration across 3 dimensions: system architecture, circuit design, and underlying devices circuit technology. Europe, being the birthplace of graphene, places significant emphasis on strategic layouts for graphene applications. As of January 2013, the European Commission envisaged listing the graphene flagship program among the initial future emerging technology flagship programs. Similarly, the Japanese government prioritizes the development of carbon-based electronic technology, encouraging both academia and businesses to engage in related research endeavors. This commitment extends to substantial investments by prominent Japanese companies such as Hitachi, Sony, and Toshiba, dedicated to advancing the research and application of graphene. Carbon-based chips offer numerous advantages, and various countries and regions have actively engaged in research and development in this field. Turning our focus to China. Researchers at Peking University have been delving into carbon-based chips since 2007. In January 2017, the team led by Zhongji Yang, Peng Li, and Mao at Peking University achieved a significant milestone. They successfully crafted a 5-nanometer gate carbon nanotube commerce device and introduced a novel method for purifying and self-assembling monolayer tubes. This marked the first instance of China mastering the world's most advanced transistor technology. The breakthrough surpassed the developmental challenges of carbon tube electronics, showcasing the performance benefits of carbon tube devices and integrated circuits in comparison to traditional technologies. China pioneered the production of undoped carbon tube MOS transistors, demonstrating exceptional performance that outpaced traditional silicon devices. This achievement laid the groundwork for the practical application of carbon-based integrated circuits, serving as the fundamental technology for crafting 5-nanometer carbon-based chips. Importantly, the process technology developed in China is not only capable of mass production, but also stands at the forefront globally. In May 2021, the Peking University team achieved yet another breakthrough in carbon-based chips. They devised a new process to achieve the orderly arrangement of high-purity carbon nanotubes. Subsequently, China unveiled its 8-inch graphene wafer, successfully addressing the graphene purification challenge that had posed difficulties for numerous American companies. The introduction of the 8-inch graphene single wafer signals imminent significant transformations in chip technology. If China can lead in commercializing carbon-based chips, it has the potential to bring disruptive innovations to the entire chip industry. This reshuffling would impact production technology, equipment, and materials across the board. As per recent reports, the production of this type of graphene single wafer has entered small-scale mass production. China has initiated the strategic planning of graphene carbon-based chips, marking the commencement of a foundation for the country's future chip manufacturing endeavors. China is actively endorsing the development of carbon-based semiconductors. In 2021, the Ministry of Industry and Information Technology directed its focus towards crucial technological breakthroughs and innovative applications, reinforcing industrial policy guidance. This effort involved integrating carbon-based materials into the 14th Five-Year Plan, with the goal of achieving comprehensive advancements in key core technologies. The objective is to enhance the quality of carbon-based new materials and other products while promoting the modernization of the advanced industrial foundation and industrial chain. Mao, an academician at the Chinese Academy of Sciences, expressed a sentiment of resilience, stating, "We have been on the road of carbon-based integrated circuits for 20 years, and we haven't encountered any obstacles that make us feel that we can't continue." These words have sparked hope within the Chinese semiconductor sector. Painley and Mao proudly asserted, "Our carbon-based semiconductor research stands at the forefront globally. China's advanced research outcomes will eventually find practical applications, and carbon-based technology can be employed in national defense technology, satellite navigation, weather monitoring, artificial intelligence, medical devices, and other fields in the near future." The advancement in carbon-based chip technology holds promise for the growth of the chip sector in China. It not only paves the way for Chinese chips to navigate through Western trade barriers, but also initiates an era of independent innovation, addressing developmental challenges within China's semiconductor industry. Amidst the challenges posed by the U.S. trade war, carbon-based chips have provided a strategic avenue for Chinese chips to gain a competitive edge. The successful development of carbon nanotron system materials, the pivotal components of carbon-based chips, has essentially equipped China with a crucial advantage akin to a much-needed supercar. In a scenario where the size of silicon transistors reaches its limit and chip performance improvement becomes constrained, carbon tubes could emerge as a pivotal juncture in the global chip industry. The initiation of mass production for carbon tubes might signify the day when Chinese chips make a significant impact. Currently, it appears that China has established a leading position in the realm of carbon-based chips. The introduction of 8-inch graphene wafers indicates the potential for domestic chips to surpass their counterparts. However, acknowledging that this achievement is not sufficient, the trajectory for the ascension of domestic chips must persistently advance. Both carbon-based chips and silicon-based chips need to seize opportunities for continued progress. What's your take on the future of carbon-based chips and their impact on the global semiconductor industry? Feel free to share your thoughts and perspectives in the comments section below. Don't forget to become a part of the Revel Discovery community by hitting that subscribe button to stay informed about the latest technological advancements and innovations. Remember, as we delve into the realm of technology, the possibilities are limitless, and the future is filled with exciting discoveries. Keep exploring.